Today we are going to review the number of ways an event can happen. We're going to review some probability and some odds as well. In how many different ways can you arrange 10 first graders, 4 boys and 6 girls in a straight line? Okay? Arranging in a straight line, the word arrange there tells us that order matters, which means we are going to use a permutation. Okay, we're arranging all 10, and we're choosing from 10. So 10p10 will tell us that number. So math, probability, option 2. And I should have put a 10 in first, so 10, math, probability, option 2, 10. So 10p10. So that's 3,628,800 ways. And how many different ways can you form a line of only 3 first graders? In a line, again, we're talking about a lineup, and order is going to matter. So we are choosing from 10 students. We're doing a permutation again because order matters. And this time we are choosing only 3 of them. So 10p3. 720 ways to arrange only 3 of them in a line. In how many ways can we pick a group? So a group order does not matter. 3 girls and 2 boys. So and we're talking about a compound event. Okay, so we're picking 3 girls, so we're picking a combination of 3 out of the 6 girls, and means we're going to multiply the events, a combination of 2 out of the 4 boys. So 6C, so this is option 3, 3 times 4, C2. So that is 120 different ways to pick that group. Alfano's offers 12 vegetable toppings and 5 meat toppings. And I don't know if that's true at Alfano's here in town. I don't need emails or phone calls telling me the actual menu. 12 vegetable toppings and 5 meat toppings. Find the number of different ways you could select a meat topping or a vegetable topping. So 1 meat topping or 1 vegetable topping, or tells us that these are mutually exclusive, one or the other. There are 12 options of vegetable, there are 5 options of meat, there's 17 different ways to choose one of those. A meat topping and a vegetable topping. So now we're talking about 1 meat topping times 1 vegetable topping. There are 12 ways, 5 ways to choose a meat topping times 12 ways to choose a vegetable topping, for a total of 60 different ways. 3 meat toppings, so now we're talking about a combination of 3 out of the 5 meat toppings, and, so more multiplication, a combination of 2 of the 12 vegetable toppings. So that's a combination of 3 meat toppings out of 5 times a combination of 2 vegetable toppings out of 12. 5C3 times 12C2. And that is 660 ways to choose those pizza toppings. And in the word pineapple, how many ways could we arrange these letters? So this has some repetitions in it. There are a total of 9 different letters. So N is 9. Among those letters, 3 of them are P, and 2 of them are E. Okay, so this is n factorial over the repeats factorial, so it's 9 factorial over 3 factorial times 2 factorial. When I put this in the calculator, I want that denominator all to stay together, so I need parentheses here. So 9 factorial, so that's math probability option 4, divided by parentheses 3 factorial times 2 factorial. Close parentheses, 30,240 ways. Okay, the word builder. How many ways could we arrange the letters? And there are no repetitions in this one. If the first and last letters are vowels. So there's 1, 2, 3, 4, 5, 6, 7 letters. And we're going to have to come up with a number of possibilities for each blank and multiply them. But knowing that the first letter is a vowel, the last letter is a vowel. So how many vowels are in this? U, I, and E. There are 3 vowels. So there's 3 options there. Now there's 3 vowels here, but I've also already used one here, so I've only got 2 vowels left. There are 7 letters total. I've now placed 2 of them, leaving me with 5, then 4, 3, 2, and 1 choices. And I multiply these numbers straight across, and that gives me 720 different ways. Okay, how about if the second letter is a consonant and the fourth letter is the letter D? Well, there's only one letter D. If there were 3 vowels, that means that 4 of these letters are consonants. So I would have 4 here, but D is a consonant, so I've actually already placed one of my consonants, leaving me with only 3 more consonants to choose from. I have now placed 2 of my 7 letters, leaving me with 5, 4, 3, 2, and 1. And when I multiply those numbers, I get 360 ways. What's the difference between a permutation and a combination? Very simply, a permutation, order matters. Lineup, arrangement, things like that. In a combination, order does not matter. A group would not have order. How many different ways can you arrange 8 different spokes on a wheel? Okay, so arranging around a wheel is a circular permutation. And a circular permutation is n minus 1 factorial. So for this case, it would be 8 minus 1 factorial, which is 7 factorial. 7 math, probability, option 4. 5,040 ways. Three students are chosen randomly without replacement from a class of 7 freshmen, 5 sophomores, 10 juniors, and 4 seniors. Find the following probabilities. The probability that all are freshmen. Okay, so the probability of 3 freshmen, or the probability of all freshmen, and we're choosing 3, so it would be 3 freshmen. So there are 7 to choose from. Okay, and I know it's 3 freshmen because it says 3 students are chosen. 7 to choose from, we're going to choose 3. That's the event. Sample space is choosing 3 out of the entire student population in this class, and there's 7 plus 5 plus 10 plus 4 students for a total of 26 students. Okay, now that's going to be the same sample space for all of these. Okay, so 7C3 divided by 26C3. And I'm going to ask for this as a fraction. Math, enter, 7 over 520. Okay, so that's your probability. Now I want to add to this the odds. If there's 7 ways out of 520 for probability, 520 minus 7 tells me that there's 513 ways of failure, so that's 7 over 513. That would be my odds. Okay, 2 seniors and 1 junior. So 2 seniors would be 4C2. 1 junior would be, let's see, there are 10 juniors, so 10C1. So 4C2 times 10C1 divided by 26C3. And as a fraction, 3 over 130. If there's 3 ways of success out of 130, then there are 127 ways of failure. 3 over 127 would be the odds. 3 sophomores or 3 juniors. So that would be 5C3. Or means plus 3 juniors, 10C3. Now if I'm adding, I better put this numerator in parentheses. 5C3 plus 10C3 divided by 26C3. 0.05. Okay, and then math, enter, 1 out of 20. That's my probability, which means there's 19 ways of failure. 1 out of 19 would be the odds. And then not any freshmen. So the non-freshmen in this class, let's see, there are 7 out of 26 are freshmen, which means 19 of them are non-freshmen. 19C3. 19C3 divided by 26C3. Let's try that again. $969 out of 2,600. 969 ways of success out of 2,600. Okay, so if I turn that into odds, I would subtract that from 2,600 and get 1,631, so it's 969 over 1,631 to my success to failure. On a particular day, the probability of a rainout is 7%, and the probability of a Rangers winning, if they do play, is 55%. What is the probability that they actually play? First of all, the probability means that there is no rain, and then that they win. Okay, so the probability of no rain. There's a 100% probability of some kind of weather. minus that 7% probability of rain is going to leave me with 93% that they're actually able to play, times that 55% probability that if they do play, they win. So that's 0.93 times 0.55. There, that is 0.5115, or a 51.15% probability that they play and win. What are the odds of a win on that day? Okay, so success is 0.5115 out of 1. So 1 minus 0.5115 is 0.4885, so that's the ways of failure. So it's 0.5115 over 0.4885, success over failure, but we don't want to leave decimals in a fraction. So 0.5115 divided by 0.4885, and as a fraction, 1,023 over 977 ways of success over ways of failure. That's our odds of playing and winning.